All right. So again, Andy, thank you so much for being here and being willing to present to the open source working group for AMIA. We've got, a lot of people who I had said, or several people who had reached out and were very interested in the recording. So again, thank you for being willing to allow this to be recorded today. So just as a brief introduction, but Andy, I'm happy to let you introduce yourself. I mean, you've Dr. Andrew King, you're at University of Pittsburgh, and you are both in the Department of Biomedical Informatics and the Department of Critical Care Medicine. So that seems to be the focus out of which the simple EMR system kind of grew. But I'm very interested to hear more about you, your interests. You obviously have a lot of expertise in software development, software architecture, how this project came about, and just to see everything that it does. So Andy, with that, I'll turn it over to you, and thank you.
Sounds good. Thank you, Luke. And I'm glad to be here to introduce my work to all of you guys. As you said, I'm going to give basically a brief motivation for this work that I'll be presenting. It was a paper that recently got published in JAMIA Open, and then I'll just demo the system. Shouldn't be a real long presentation. I just wanted to get this work out there, and if it's of interest and helpful to people, I'd be happy for you to use it, contribute to it, anything like that. Basically, the idea of the system. Let me do a screen share here. All right, you should be seeing my Chrome browser right now. So this is the paper we're talking about, a simple electronic medical record system designed for research. And for it, we have this interface right here. I'll be demoing the system a little bit later, so you might get a better chance of seeing it then. So this is a web-based EMR interface that displays patient data. De-identified data. It's not meant for PHI or anything like that. It's meant to support research. And what this project came out of was my dissertation work, where we were interested in predicting the information usage patterns of physicians so that we could adapt the display of information for them to better meet their workflow needs. The physician population we focused on for that project was critical care physicians, specifically fellows and residents, who were reviewing patient records in order to prepare for morning rounds. So this is a very data-intensive task where a physician reviews lots of different information in order to get a complete picture of the patient case in order to present it to the rest of the team and make a plan for the day during morning rounds. ICU patients in particular generate lots of data where they might have a lot of various real-time physiological data. They're on a variety of medications. They might have different therapies, such as they might be on a ventilator. And then there's a plethora of laboratory tests as well. So in this work, the idea was, could we, somehow track how physicians use the EHR, build a machine learning model to predict for this given patient what information would they want to see on this particular morning, and then adapt the EHR in order to highlight before that work, we did a few different paths. At my local institution, the affiliated hospital is UPMC in Pittsburgh. They use Cerner for the inpatient EHR, and there was lots of barriers to using Cerner for actual research applications. It's difficult to control the user interface and make changes. It's also difficult to get the granularity of metadata we want. We really, at the individual laboratory test or vital sign level, want to know what information it is that a physician is looking at in a particular context. So the solution we decided on was, rather than handicap ourselves by trying to use the Cerner system, we developed this web-based EMR system that really just handles the display functionalities of patient data, and we built it around the needs we had for our study. And those needs were, present the data, let physicians review the data, and then in some way capture what information they were viewing. And then after we apply our machine learning models, then we can adapt the display of information to meet that. So that is where we ended up deciding to develop what is now called the simple EMR system. When we were presenting some of that past work of our changes to our layout based off these machine learning models for the learning EMR, we realized that in those presentations, people were really interested in this system we developed just to support the research. And so after getting some feedback on that and, request if it was, if it could be used for other projects, I decided to go ahead and adapt the code to make it more useful for others. Because really, it was really hard coded to meet my needs. It was not in any sort of shape to share with others. So I did a lot of refinement work to make it more generalizable to other use cases. And, I view this just as a starting point. I really, the reason we open source this project is because I really think there's a lot that others can contribute to and build on. This isn't even something that I'm, currently actively developing further. I will continue to develop it as needed for my own research and my own studies. But as other users have other needs, then, I encourage them to contribute to this project and use it however they need. Okay, so that's a bit of a background on what it is we were trying to achieve. So I'll go over this, a few figures in this paper in a minute, but why don't we go ahead and look at the actual user interface. So first, the system is available on GitHub. It's called the Simple EMR System, and it's available under my user account, AJK77. If you download the system, there's some brief installation instructions that tells you how to, how to clone it, how to create a virtual environment for running it. But it's using the Django, the Bitnami Django stack, so you can really just go into the product directory and then Python manage.py run server, and it'll run locally in your browser just like that. There's also a Docker version if you prefer to work in Docker. After you do that, what you find is, apologies. Okay, there we go. After you do that and run the system and go to the browser, you will find a landing page that looks like this. Welcome to the Simple EMR system. And this is a study selection screen. And this is going back to, this is some functionality I added to help support other researchers. So from here, you can, select a study. So I'll go over how to load in different studies and different users later on in the talk. But so basically you select your study, then you can select what user you currently are. And then you'll have a list of cases that you're assigned to complete. So I'll just click on this first case and it'll go into the user interface. Now the data you're seeing here is from, it's basically synthetic data at this point. It was, let me get the zoom right for the screen. It's synthetic data. It originally came from de-identified data from UPMC, but I scrambled values, shifted date time, shifted everything. So more or less it's synthetic data. So I'm just saying that because if some of the test results and vital signs don't quite match up, it's because it's not a real case. It's simulated in that sense. But anyways, whenever you go to a case, you'll land on a patient. It'll tell you some quick information. So, admitted on this date, currently ICU day 4, and it's saying, please use available information to become familiar with the patient. These are the kind of things that you can customize for whatever your study need is. But you can click OK. You'll, see the patient data. Basically, we have vital signs on the left side of the screen. Below that would be any ventilator management information. You have intake and output below that. You have all the medications in this panel here, where it's currently arranged by the route that the medication is given it. In this middle column, you have the laboratory test results organized by laboratory panel. On the right side, not will be where things like or progress notes, radiology reports, any sort of free text stuff, procedures would be displayed. In the default data that you can download from GitHub, none of that's in there, again, because this is synthetic patient cases. Other parts of the screen, up top here, I'll start back up there. There's a home button if you wanted to go back to the patient selection screen. There's the user ID, some demographics about the patient, and as well as this time selector piece, which was if you wanted to see more of the patient's history, you can zoom back in time. All of the different laboratory tests will update. You can see that above each column of data, there's kind of like your x-axis, which has dates on it. Same with the bottom of the screen. You can zoom in to a smaller window of time if, say, you only care about the last few hours of data. Whenever we look in at individual laboratory tests, I'm going to zoom in. It's going to mess with the formatting of the whole screen, but I'll zoom back out before we go back to navigation. Let's see if this works how I want it to. All right, yeah, so this is just to make it more readable for you guys on the call, because I'm not sure if the size was big enough over. Okay, sorry, let's go back into that case. Okay, I'll zoom in on a still picture because zooming in on the browser is not working like I wanted.
That's okay. And I can say for me personally, it was okay. I appreciate you thinking.
Was it big enough? Okay.
For me, yeah. I'm not sure if anyone else on the call disagrees, but for me, it was
Works
okay.
for me.
Okay, so then let me get it back to where it was, because as you can see, it doesn't, the responsive HTML, it's really meant to be full screen on the browser. Okay, so this size is about what it needs to be. Okay, so what we'll do to zoom into an individual laboratory test result, I'll look at a still picture later, a screenshot where we can zoom in a bit more. But to give you a little bit more detail, you'll see on each of these, there's dots for the different data points, whether it's a measurement or say a medication administration. There are normal range bands, which you'll see in the shaded blue region. And for laboratory tests that are within normal range, they show up as green, above in red, below in blue. And then you also see this tan shaded region on the right side of the screen. That just shows the most recent 24 hours. So if you signed in this patient today, it happens since yesterday, and that's helpful whenever you're changing the scale of the y-axis, because sometimes it's hard to keep track of that. And if you hover over a point, you'll get the exact value of any of the measurements. In the upper left, you'll get the test name or element name, whatever it is, and on the upper right, you'll get the most recent value and the units of the value. Again, these kind of design decisions were largely, created based off of our needs for our studies. It might be the case for other studies, different sort of design decisions will need to be made. Some people might even prefer to have more of like a table of numbers type of display that EHRs pretty much display it by default. But anyways, as far as study navigation, after the patient would review the case, they'd click this continue button down here. And for our study needs, we basically just advance the data one day forward. So now it's ICU day 5, 24 hours into the future. And the task right now is please select the information you use when preparing the case. So this is when they would review the information again and then select by clicking on the data elements that were needed for the case. And then they could click the continue button again, and this case was complete. So then they would have one more case left based off of the data shown here. All right, now I'm gonna go to just some of the figures from the paper. All right. So the user interface itself, we wanted to separate the different components so people of different computer programming literacy would be able to use the system. So using the Django framework, it is a type of model view controller setup where if you wanted to change the patient data displayed on the system, you have a couple different options. You could input data from a database. You can see by default the system connects to, it has code for connecting to what our local SEMR research retrospective data was, which wouldn't be useful to others, but it does include the transformations in ETL for if you were using Cynthia data, which would come in a CSV format. Or eventually a possible extension would be to connect it to a Fire server and load it with that sort of data. As far as processing the data, the main thing is whatever your data source, you'd have to look at and or create your custom load data.py Python file. That's how you convert it into a JSON format, and that's really this JSON format is what the system reads whenever it's displaying data. The reason we did it this way is twofold. The JSON data as it's stored is exactly what needs to be served up to the browser, so it helped with load time. That it's already there's at actual runtime, there's no transformations that need to be made to the data. That's all done ahead of time in pre-processing. And then also this has the advantage that if a user wanted to tweak patient cases or create their own, rather than going through this process of adapting to different sources, they could, in theory, just go to the JSON files and customize it however they want there. So if you only need a couple cases or you need to make tweaks to existing cases, you can do that in the JSON file and that'll be reflected back on the actual user interface. And the next part is the controller. There's in the Django stack, there's a views.py file that really runs everything. It pulls in the data and the HTML templates and displays it in the browser. So with this, there's also some study configuration JSON files. So this is where you would set up, how many users you have, what cases they're supposed to review, what sort of instructions you want for each of those cases. And you'd set up configuration files for each study that you wanted to load into the system. And then the views.py, the views file runs that. And the third thing you can manipulate is the actual display of data. And that's using template files in the Django language, and that'll change what's displayed on screen. And then any sort of results that your users do, that goes back to the views files for handling and is stored in some sort of experimental data, text files or JSON files, whatever it is you want. So really with the separation, you can change patient cases by working up here in the model part. You can change your study configuration data by working with the configuration JSON files, and then you can change the display of data by working in the template files. So depending on what your needs are, these are the places you would end up making modifications to the software. Just a little bit of a zoom in on some of the concepts I mentioned before. Again, there's that time selector on the screen where you can drag back and forth just to select which of the patient data is showed at any one time, where basically patient admission to the hospital would be on the far left side, and then whether it's patient discharge or whatever the most recent data is would be on the right side. On individual data fields, as I said, you had the test name, most recent value and its units, the range of it. The blue band were normal ranges if they were available to the system to plot. The tan band is the last 24 hours, so that'll get bigger or smaller depending on how large of range you selected. By default, it's set to 3 days of data. And then each data point is individual measurement. The data was organized based off of laboratory panels as far as the test results go. And I didn't show this, there's going to be a new update push to fix an error that was found in how this works. But whenever a user is manually selecting data, basically, whenever that task is assigned, these extra checkboxes will show up on each of the laboratory test results and vital signs, all the different data elements. And whenever you click on anywhere within the panel, it'll put a check mark in it, change the background. And then whenever you basically click continue or submit the data, whatever is check marked, that's what'll get stored back in the database. So that was for the task of selecting, information that was relevant in a given context. For other studies, a similar sort of task might be useful. So that's one of the functionalities being included. And then, as the reason we're having this talk is that it is, I want this to be an open source project. I want others to contribute to it. Other ways of doing that, we can do out of the box connection to other common databases such as, mimic data. That would be great. As it's currently envisioned, the layout of the system is really meant for inpatient, particularly patients with lots of data, such as ICU patients. Other customizations to the interface could be made to make it better fit to, say, an outpatient setting. One thing I didn't talk about is we also did some eye tracking work where rather than forcing users to actually manually click on the information they use, we connected a $150 eye tracking device, the Tobii IX, which is meant for video games. There's a separate package that has some of the code for that. That is the way I implemented it there's a lot of restrictions on exactly screen size and everything like that. So I didn't include it in the initial push of data for the simple EMR system, but that is something that could be added in the future that better works with responsive HTML and when the user interface changes, and how to make sure that the eye tracking and automatically mapping of what users gazed at back to what was displayed on the screen at that point in time would work more consistently.
Could you repeat, because you broke up a little, about what the problem was? The eye tracking in the very beginning, you said there's a lot of restrictions on something.
Yeah, so I hard coded the eye tracking to, here, let me go back to the user interface. So really the only problem with the eye tracking was that it was really hard coded to work. The screen had to be completely full screen, and the actual running the scripts for using it. I was just worried that if I included out of the box, there might be someone who naively uses that functionality in a way that the data, it could affect data quality issues. I can provide a pointer to code for including that, but basically there's no reason why it couldn't be pushed back in. I just didn't include it in this current form of it, but the way it works is basically you would, each of the elements as they're displayed on screen, you tag it with like a CSS class that JavaScript then knows to track where that object is on screen. And basically, as you scroll or there's any sort of page refresh, it sends where all the data was on the screen and stores that to a file. And at the same time, the eye tracking stream of data, so XY coordinates plus a timestamp, is saved to another file. And then there's a bunch of scripts for mapping the two together.
And this eye tracking is open source too, I trust, right?
Yeah. So I'll show that as well. And the only other reason I didn't include it was because when that's running, sometimes it does slow it down just a little bit, like when you're scrolling, which is no problem if you're using the eye tracking data and getting good information out of it. But it also requires a couple different settings on your browser to be set. For instance, if you're using what was it, Firefox, There's like a setting on Firefox that gives it a really smooth scroll. But whenever that's happening, it's firing the refresh command like many times a second. And then that would, because it was storing each of those positions, it was like, that would slow it down. So like you had to, within the settings of Firefox, I had to like shut that off to make sure that it wasn't refreshing, you know, too many times in a row. But all those issues are solvable. So let me show you where to find that information. And if this was something you were going to use, feel free to reach out to me. My email is andrew.king@pitt.edu.
Okay, thank you.
So that package is called iBrowser Pi.
All right. Can you drop that and go back to that just a sec so I can take that picture, a picture of that screen?
This one here?
Yeah, it'd be good if I quit dropping my phone here.
Yep. No
I got
problem.
it. Thank you very much.
Yep, GitHub AJK77. Just real quick, I'll go over these. The simple EMR interface, that's the one that I've been presenting, where basically you can clone the system and pretty much get it up and running fairly quickly. Learning EMR interface was a less refined version of the simple EMR. So I wouldn't necessarily direct you to it. It's still in here just because some of my past published work has links, pointers to it. So I don't want to break those links. So it still exists. iBrowser Pi, which I'm about to open up, that's where it shows you some of the eye tracking code and scripts. So it is more directly correlated to the code that was in this Learning EMR interface. So if you were going to use that, I would mostly recommend like going through it, getting an idea of how it's functioning, and then adding those parts into the simple EMR to get that working. And then Patient Pi was just another package I've created that is basically, it was extracting patient data and then doing temporal transforms on it. So finding slopes and most recent values, and in order to output like vectors for machine learning. But that's just another thing that we have out there. Yeah, so as far as the eye tracking is concerned, if you go to the iBrowser Pi, there's the 2 papers we published on it. And like I said, having a look at this code and then the Learning EMR code will give you a sense of how the Python, the Java, and the JavaScript work. So what you need to do for the browser, and then how the analysis. So this would be like the scripts that map the stream from the eye tracker to the stream from what was displayed on the interface. And I'll actually open up this paper and look at one of the figures. Yeah, so like I said, when you're using eye tracking, this is just a figure showing, you store coordinates of each of your data elements, timestamp and XY coordinates of where the gaze points were. And then there's algorithms for mapping those together. And for my case, I just cared about what elements were viewed. All right. Yeah, so pretty much that was what I have today. I'd happily answer any other questions about the interface or the eye tracking. Also, I do admit I haven't really contributed to open source projects before. So if any of you have advice for how to better set up the repository, or if there needs to be a wiki or anything like that to better support this work, I'm all ears on that. Looking for partners or students or anyone to continue this work or use it for their needs.
This is really interesting, Andrew. I have small question. Do you have version control?
Just whatever GitHub has in there. So
Okay, so, but you don't like say this is version, 1.2, 1.7, 1.8. It's the version control that GitHub does for managing what's changed in your code base. There's not like a release version.
yeah, that was one of the that's one of the things I want to add. So it would, so somewhere in here, right, you can make like tags. Yeah. So so in terms of version control, I should just make tags. So like I would tag like this was the version when this paper was published, and then others would add to that.
Yeah, I don't have a suggestion for how to do it, but I do think that it's helpful so that people can know which version they're using if you get traction and other individuals are using it.
Mhm. Yep, I appreciate that.
You got some of it there. Looks like got upgraded to version 3. So
Yeah, so yeah, to some extent there, but I don't necessarily have tags to, what version 1 or version 2 would have been. And in reality, those version 1 and version 2 would have been back on this version of the code.
yeah, over there. Yeah.
Which hasn't the security vulnerability. So obviously I haven't been maintaining this as much, but yeah, so what's currently released is what was released with the paper, and I guess that would be version 3, but I think I better tag that, and then any future iterations on that should continue to create tags.
Yeah, so I'll talk a little bit more about that, because what I'm thinking is, unlike with proprietary software, you have no obligation or requirement to upgrade an open source system that you're using, right? So you could be using version 1 or version 2, and it could be up to version 10. And so the value for the user and obviously the work for the maintainer is to say, this is what's changed from version 1 to version 2. This is what's changed from 2 to 3, so that people can decide if they want to upgrade to the current version, or if the version they're currently using works fine for them and there's no reason. So usually there's a change log that indicates what's changed. And that, unfortunately, Git is not going to manage for you. That's something that a person actually has to write what's changed. But those are the advantages that you get from an open source project, as opposed to just a free and open repository where people can pull the code. So I think that you've done a lot of great work. Unfortunately, I think that it needs more documentation, and nobody who likes to code likes to do documentation.
Mm-hmm. Yeah, I hear you on that. The documentation piece, that was on my to-do list since the paper was submitted. It was like, all right, before this is published, I will dig in and get all this documentation. So I hear you on that, and I will continue to do that. So with that said, within the documentation, would it be, there's obviously within inline comments, but where should the documentation lie? Like probably within this wiki here, right?
Yeah, I think you can be flexible on that. Wiki is a place. You can also have a directory in Git that does it. And you could even probably automate some of the things that pull your internal code out and put it in that other part of the repository.
Mm-hmm.
Right. I think a lot of our coders that post their stuff up put a directory with documentation in it.
Okay. Yeah, that makes sense.
And-
I'm sorry to keep going back to this. Could I quickly ask you again about this eye tracking? Unfortunately, I'll admit, I'm not wondering about it so much for yours as for one of our projects. You said it uses a device that's used for gamers to track their eyes or something?
Yeah, so let me just go to their website. The one I bought was called Toby IX. Their newest version, which we bought one to make sure it still worked, was called Toby 4C, but it looks like now they might be all the way up to Toby Eye Tracker 5. So this one I haven't tested out with my scripts, but yeah, you can see, I guess the price is a bit higher now, but it's $183. And it really just, it snaps to the bottom of the computer monitor. It comes with like magnets for doing that. And so what it is they have, you know, development tools for working with it. We did not use the developer tools. We just, I just used, someone on GitHub had like basically Python wrappers for you know, using their JavaScript for using it. So all I get out of the eye tracker is, like I said, the timestamp plus the X and Y coordinates of, I believe it's of each eye, and then I just kind of average them if they were within a certain amount of each other.
Very good. Thank you. I'm sorry to bother you about that.
Oh, no, absolutely not. I mean, I think this was really, you know, this was really neat work that we put together and did. So I would love to, if I get back to it, eventually, you know, add either better integrate eye tracking with the current code release, or I guess that would be a version 4 that would include the eye tracking piece of it. Now, admittedly, I will say the, yeah, there's a few, yeah, like I said, there's just extra steps in order for integrating the eye tracker. So that the installation of it would be a little bit more complex.
Yeah. So I assume that gamers use it for interface design, right? Or not? Do you know?
Yeah, so the idea is, like, say you're playing a game where you're flying in a cockpit, and if you turn your head to the left, you know, the character you're controlling, you know, they'll view will look to the
Oh,
left.
I see. It's okay. Yeah.
Yeah, that's kind of how they use it. There's also some accessibility use cases they have for it. And
makes sense.
also a neat use I saw was, like, it was a game where they were walking through a cave, and in the cave, the lighting was like torches hanging from the wall. And if you looked directly at the torch, then your view would be obscured for the next few seconds, like you lost your night vision. So it's kind of neat, immersive use cases. Now, admittedly, the software specifically says that you're supposed to be using it for interaction, not storing past eye tracking data. And I think that's partially because they, you know, they have Tobii has a whole division of research grade eye tracking equipment that includes those functionalities. But, you know, we were able to get it to work for our use case.
Now, I was just thinking about it for interface design for an EMR. You know, the GUIs, you know, what would make it easiest for people, and, you know, what order they use things in and how they're getting confused or whatever. It might help.
Yeah, and we've even thought of, you know, a potential good application would be to relieve alert fatigue. Like, you know, we trigger alerts for many different things. Well, if we know from the eye tracking data that a physician already looked at a particular piece of information, maybe we could silence an alert that.
I like that idea. That's very nice. Yeah, because you can track what they opened up, but you have no idea. If you don't know what they looked at, that doesn't help you.
Exactly. Yeah, so if that was all the questions, I'm happy to hand it back over to you, Luke. Like I said, anyone, please feel free to reach out to me. I'm happy to hear how you use systems. If you have questions about the specific code, let me know. That's the kind of thing I should get into the documentation, because I'm sure others will have the same questions that you come across.
Yeah, if I may chip in there. So first, congrats on the work you've done, because I think it looks really nice, and I think it can really fill a gap in well, easing being able to do research on well, usability and interfaces of EHRs. I was wondering if you have any either hands-on or maybe second-hand experience on really applying this software for doing such research or an evaluation.
So specifically, like this system, yeah. So yeah, it was all developed kind of secondary to my dissertation. So I was, you know, I was running research where for the learning EMR, there was 2 phases of the study. First, we wanted to collect information, viewing patterns for a set of cases. So for about 200 cases, we had ICU fellows review the patient cases, and then they'd select the information that they view that was relevant when reviewing that case for morning rounds. And then from that data, I built machine learning models where the predictor variables was a vector representation of the patient state. So like the laboratory test results and different temporal features of them, the demographics, the procedures the patient had in the past. And then the targets were, for this case, at this point in time, which of the test results and which of the vital signs did the physician want to look at? So we weren't predicting values of these tests. We were just predicting the state of wanting to view it for this patient. And then we applied those models to 18 patient cases. And then we had a new batch of fellows review those cases. And for that, there was, we would highlight the information in different ways. So for the control, the interface would look the same. For the intervention arm, we would highlight the background colors of the items that we predicted them to use. And then in a second intervention arm, we would only show the information we predicted they would use. And actually, I have a paper on that is relevant since we're talking about it, that I can show a figure from. Okay, so yeah, this was where for the, let me do high res. So yeah, so this was applying machine learning models. This was done in a laboratory study. Again, it wasn't actually during patient care, but so based off of our model output, we highlighted the background of what we predicted they would view. So they would, so say for this given patient case, they would review all the case data up to ICU day 3. And they'd press, so they were familiar with the case, they'd press continue, they'd get 24 more hours of information and have the task of, prepare to present this case at rounds, and these items would be highlighted. And then the other view we tested is we only showed those items to see what would be highlighted.
So, oh, go ahead. I'm sorry.
No, go ahead. I was just confirming. Yeah.
So, Andrew, I was just thinking, Pittsburgh probably has an affiliation with the VA hospital, right?
Yeah, they do.
So World Vista uses the VA software because it's open source. And I'm just thinking that might be helpful to you, because you could make your system up and get everything working, and then, I don't know, potentially get permission to use your eye tracker and film something in a real situation to figure out what's getting focused on for real. I don't know, just throw it out there as a thought. I don't know if you knew that electronic health record was open source.
Yeah, no, I think that is a great suggestion, and that is something I'd like to explore further. But my one concern is the VA, aren't they all switching over to Cerner? So
yeah, but it's you've got, you may be in your grave before they get there. It's going to take them at least 10 years. The very first implementation they've done has gotten the brakes thrown on because of all the problems they're having. They've adapted Vista to work for the people in the VA, and now they're throwing something at them that doesn't work very well for them, and it's not going too well. So I don't think they're going to back down and not do it, but they're having so many problems, it's going to take a long time.
Okay, yeah, so there might be a window in there to prove this out in a real EHR, and then that would potentially justify the further implementation in additional systems.
Yeah.
Very cool.
Andy, would you mind if I ask a couple questions?
Absolutely.
Is that okay? Thank you so much. No, and again, I just want to echo how great this was. It's just, I mean, it's impressive reading the paper and just seeing it in action and like how responsive everything is. It's very, very cool. So thank you for clarifying as well, because I was wondering when you were talking about that it captures like the data that somebody's using as part of the system. Thanks for clarifying the way that it's like capturing the panel. I wasn't sure if it was doing it at kind of the panel level, or not panel, but you know, the laboratory itself. It's not like a specific data point, right? It's yeah, which I think makes a lot more sense. Do you, and again, this is a question because what I'm seeing is exciting, and not that you should have built this, because you know, I don't know that there would have been any use for it in your study. But with the notes view, is that also something that outside of the eye tracking integration that you had considered capturing? Either that they like click the note to say that they use that information, or something even like highlighting specific snippets, kind of like a text annotation, like text annotation tools do? Yeah,
so the answer is yes, we did capture it, but we did not get to use it in any of these studies. So while we were doing the eye tracking, as far as the notes go, we tracked, you know, which note was currently being displayed, where, you know, we are already tracking the eye tracking position. And so the only other piece we needed was like what scroll position of the note we were in. And we captured all of that, but basically we decided that I needed to graduate, and so we didn't add that into the study. We just left that as potential future work.
Fair enough. No, that's all right. Thank you. And I think this, I can't remember, this may be in the paper or the documentation, I apologize, is so for the JSON file, that's one JSON file per patient or per case, right? It's not like JSON files split out by data type.
Well, let's go ahead and look at it, because I think it would be easier just to show.
Thank you.
What the arrangement is.
Yeah, I know in the diagram it showed multiple JSON files. I just wanted to confirm like which way it's split.
All right, so within the project here, let's see, I think it would be in resources. So basically, to define a study within the system, you would, you know, just create it, and then it would be underscore study. So there's, you know, Cynthia study and then demo study. We'll go to the demo study again. And then this is the file structure that's currently required by the system. So there would be a case details JSON, which listed the case IDs, as well as just some display information about the case, like the minimum display time and max, just in like, you know, numeric timestamp. And then would be the instruction set. So basically this structure here is, remember when I showed a case, you'd like press a continue button and then it would pop up with more instructions. So it is an array where within the array there are dictionaries containing the min and max display time, and then the instruction set. So if you have like, you know, 2 different dictionaries within this array, it would show the case twice in a row, and then this is 24 hours after this happened. So that is one of the configuration files. There's a layout file that tells you like which panels go into the lab panel groups. This is just different ways of configuring the user interface. Same with medications, and so with details about the individual meds and what route they were given by. One suggestion that would be helpful though would be, you know, rather than organized by route, more to organize it by like clinical indication. So, you know, put all the cardiac effective drugs together. There's a user details JSON where you define who your system users will be, which cases are assigned to them, which cases they completed already. And then a variable details, which for each of the data elements, okay, this is where it tells you what group to display that element in, what display name it should have, if it has a normal range, what its max and min range should be, what its units are, if there's just a global unit for it. And then into the cases, there would be a folder for each case. And within that folder, there's just 3 that were, so you have demographics, medications, any notes data, and then observations. And each of these will just be a dictionary that tells you those values. I'll look at the observations one. So an event, there's also a display text here. And then this is where the graphical package I'm using is called high charts. And so the numeric data, the way it's parsed by the load data file, it already like inserts the data in a way that that high charts can process it quickly. But really the data is just, you know, a time, an X, which is the time, and then a value. You can also put like y-axis ranges in here if it goes beyond whatever your default y-axis range is. And that's how the data is. And we did it this way. I think in the past system work, you know, these were binary files, but in order to make it easier to debug for other people trying to use the interface, we converted everything to using JSON.
I think that's good.
Great. Thank you so much. Thank you for walking through that. That was very helpful.
Yeah, absolutely.
Great. Any remaining questions?
There was a few things in the chat. Let me just make sure there were no questions there. Oh, that was just you kind of posting some of these links. Okay. Excellent.
Yeah. Yeah, and I'll include the links for everyone in the summary as well. So yeah, just so people had those as we went along. All right, great. Well, again, Andy, thank you so much. This again is super exciting, very awesome stuff. I'm not sure if people have reached out to you with potential use cases. The educational side, the research side, I mean, these all sound like fantastic opportunities. I personally was kind of curious, you know, I'm kind of wondering if this could be used as to help with chart review. You know, as like a, but I'm not sure if anybody else has kind of thought about that angle as well.
Yeah, I mean, that was part of the interest from the fellows that were using it. They were like, yeah, this would be great if this was a visualization built in. So, you know, they didn't know the words for it, but it would be like a Cerner in page or a Fire app that could be integrated and just pull the data from the record. As far as other use cases, I had someone reach out to me who was interested in using this. They wanted their project, they need to annotate notes. So they wanted to plug in an annotation tool into the notes panel so that their users can see the case details while they're annotating notes. It also is good for like classroom use for medical informatics students. So those are some of the use cases out there.
Wide range of opportunities. No, but again, that's what I think is so exciting and so powerful about it.
Right. The Vista electronic record has a graphing program in it that allows you to graph various things a little bit like you have, but you can also superimpose them, but because of the way you have it, it's the same, you know, you can see very neatly, but that helps, you know, when people get good at developing these things, if they do particular things for chart reviews, it's exactly what it's been used for. And it's been very helpful. And being somebody who did training in infectious disease, where, you know, every little detail, you know, everybody wants to know. I saw one that was developed by an infectious disease person that just blew me away. I mean, because it could take years of data and make it easily accessible. It was wonderful. Had they ever received that antibiotic or that vaccine or that this or that this, you know, it was wonderful, wonderful. So I agree that this would be really good for chart review.
Yeah, awesome. Thank you. I'm glad you're excited about it. And I think I hope this has a long future of adaptions and use cases. And, you know, I hope people like it.
Good.